All right, guys. Chapter 3, Section 1, we're talking solely about quadratic functions. There's a lot in this lesson. That's why we break it up over a couple days. We're going to have a quiz at the end of the week over just this one section. So we need to make sure that we're paying attention, taking good notes, and writing everything down. So part 1 today, we're going to talk about the quadratic form. You guys are already familiar with the quadratic form as it's written right here. F of x is the same as y. And this is in what's called quadratic form. It's our ax squared plus bx plus c, where x squared is your highest exponent. That tells us the shape of the graph. It's a u. It's going to have two x values, that sort of a thing. We're now going to talk about parts of a parabola, because that's the shape that a quadratic function makes as a parabola. And we're going to call something the axis of symmetry. The axis of symmetry is this imaginary vertical line that cuts your parabola in half. The left-hand side of the parabola is the exact same as the right-hand side. This is going to be an x equals value. It's going to be really important. It's going to be really important that we remember our x equals and our y equals on a lot of things with our parabolas. Another thing we're going to talk about is something called the vertex. And that is going to be the absolute minimum of the graph, the bottom we'll call it, or if it's a negative parabola, it'll be the absolute top of the graph. It is an XY point. It's going to be called our H and our K. You'll see that in a minute. But that's going to be a very, very, very important piece of information that we find. So axis of symmetry is our vertical line. It's imaginary, that cuts our parabola in half. And the vertex is going to be that absolute top or the absolute bottom. It's either our maximum or our minimum point of our parabola. So to find the vertex, we're going to use two different methods. We're going to first use this teeny tiny little formula that will help us. And we're also going to use completing the square. So it's going to be important on your quiz for you to pay attention to what the directions say. If it says just find the vertex, you can use this. If it says find the vertex by completing the square, then you need to do that. So what we're going to do is we're going to take this little formula, which to find the x part of your vertex, you take negative b divided by 2a, and then we plug that back in to the x to find the y value. I'll show you that in a second. We'll then plot the y-intercept. And then if we need additional points, we will use our x-intercepts or what we shall. One thing I would like to say too, guys, is in our quadratic form, ax squared plus bx plus c, your c, your constant, is going to be the y-intercept. Because think about it, if you plug in 0 for x to find your y, there's 0, 0, so your y-intercept is going to be that constant. This is another form of a parabola that you guys will notice, and this is called standard form. Sometimes this is also referred to as vertex form. Our book uses ax squared plus bx plus c as our quadratic form. And then it uses this with the vertex present as our standard form or vertex form. So what you guys are going to notice here is a is the number that's in front of x squared. And then in this part here, our h and our k is actually the points of our vertex. H is the x part of our vertex and k is the y part. And notice in the standard form equation here, this is a minus sign. So whatever number is in here, when we take it out, it's going to be opposite. We got to pay attention to that. Like we said, if you had a parabola and it said x minus 2 squared plus 3, where does this parabola move? Well, it moves to the right 2, which is the opposite of what we think, and this is y. And then this would move up 3. So your vertex would be at 2, 3. That's how you can take that out of this. So, like I just said, if we're going to try and find the vertex here, our vertex is going to be at, this is my h and this is my k. So I'm going to take this number out here. It's the opposite of what I see, so it's going to be negative 2. And then our k is negative 3. So if you were to graph this using our transformations that we learned, our normal, or our, sorry, I should say our parent function looks like this. Well, our transformations would tell us that we're going to move left 2 and down 3. So if I go left 2 and down 3, there is my vertex. That's the minimum. That's the lowest that my parabola is going to go. And then for us to find other values, we would then plug in values for x to find our y, but our parabola is going to be facing upwards. We know it's facing upwards because it's positive. Now here is a way that you're going to be in quadratic form and you're going to be asked to graph or to find the vertex, those sorts of things. So right now, looking at this, my ax squared minus bx, or I should say ax squared plus bx plus c, this right here, we talked about, our constant is going to be our y-intercept. So this graph, this parabola, is actually going to cross the y-axis at 0, 14. That's very helpful when we're trying to graph. Now, another thing I notice is this is a positive x squared. That means my parabola is going to be going upwards. So let's go ahead and see if we can figure out where the absolute minimum, and it's going to be a minimum, guys, because it's facing upwards, that's the bottom, where the minimum of our parabola would be. So to find that, we say x equals negative b over 2a. Well, in this case, my b is negative 6, so I have negative 6 divided by 2 times the a term, the number in front of x squared is 1. So I have 6 divided by 2, which equals 3. So the x part of my vertex is 3. How do we figure out what the y is? We're going to plug that in to my equation. So I have y equals, instead of x squared, I have 3 squared minus 6 times 3 minus 14. So 3 squared is 9, minus 18 minus 14. 9 minus 18 is negative 9, minus 14 gives me negative 23. So my vertex is at 3 comma negative 23. So I go over 3, down 23, and then I up here somewhere at x or y is 14, and there's my parabola. My other point on the other side is going to be a mirror image from the y-intercept, because remember, this is this vertical line that cuts my parabola in half. And that's all we're doing right now, guys, is just figuring out what the shape of your parabola would look like. But it's really important that you know how to find the vertex algebraically. Okay, guys, so on your quiz on Friday, or when we have it on Friday, you're going to be given a few equations, and it's going to ask you to find a whole bunch of stuff. You're going to be asked to find the vertex, the axis of symmetry, x and y intercepts, probably domain and range. When you talk about domain for all of the parabolas that we are talking about, your domain right now is always negative infinity to positive infinity. If you don't get anything right on the quiz, you can at least get that right. But right now, this just says find the vertex. It doesn't tell me how to find it. So I am going to go ahead and use my little x equals negative b over 2a, this little formula. So I have negative 6 over 2 times negative 1. This gives me negative 6 over negative 2. So my x part of my vertex is 3. So I'm going to write that over here as 3 comma. Then I'm going to say, okay, let me figure out what y is. So I'm going to take that 3 that I just found and plug it in. So I have negative 3 squared plus 6 times 3 minus 8. So I have negative 3 squared is 9 plus 18 minus 8. So negative 9 plus 18 is going to give me 9, and 9 minus 8 is going to give me 1. So here, guys, my vertex is at 3, comma 1. So what I like to do, what I like to tell myself at the very beginning, I like to look at this and say, well, what kind of a parabola do I have? Since there's a negative out in front, I know my parabola is going to be facing downward, right? So my vertex is here at 3, 1. I can already identify the y-intercept because that's going to be my constant. So my y-intercept is going to be at 0, negative 8. And since I found my vertex, I can find my axis of symmetry, my AOS. Your axis of symmetry, which is that vertical line that cuts your parabola in half, is going to be at x equals 3. It's going to be the x part of the vertex. So now how would we find our x-intercepts? Well, guys, what would we do? We plug in 0 for y, or f of x, and we solve. So 0 equals negative x squared plus 6x minus 8. So the first thing I'm going to do is take out that negative. So I have negative 1, and then I have x squared minus 6x plus 8. And then I'm going to see if I can factor this, which wonderfully we see that this does. What are the factors of positive 8 that multiply to give me positive 8, but add to give me a negative 6? That's going to be minus 4 and minus 2. And then I set each piece equal to 0. So -1 equals 0, not the case. X equals +4 and X equals +2. So we're asked to find the x-intercepts, guys. We're gonna write x-intercepts as points. So I have an x-intercept at 4, 0, and I have an x-intercept at 2, 0. So now I'm gonna go ahead and plot everything that I know. My vertex is at 3, 1, so I'm gonna go over 3 and up 1. I have a y-intercept at 0, -8, so 1, 2, 3, 4, 5, 6, 7, we'll say it's right there. I know my axis of symmetry is going to cut my parabola in half. So how far away from the origin is that? It's 3 units, right? 3 units this way. So I know I'm gonna have a mirror image point 3 units this way of my y-intercept. And then I can go ahead and plot my x-intercepts. I have x-intercepts at 2 and 4 on the x-axis. And then we can very gently draw our parabola. And then when we're talking about range, your range is always going to be based. Remember, range is the y-axis. So my range is from -infinity, and it goes up to what number? 1. So your range here would be -infinity, comma 1, and that 1 is included. So range is always going to have be based here on the y part of our vertex. Your axis of symmetry is on the x. All right, let's do another one. Find all the things, okay? So the first thing I'm going to do is say, okay, which direction is my parabola facing? It's up, it's a positive. What's my domain going to be? It could be anything I want, -infinity to +infinity. So let's go ahead. What else can we identify by looking at this? Oh, our y-intercept. Our y-intercept is just going to be the constant. So my y-intercept is going to be at 0, 3. Good. So let's go ahead and find the vertex. I'm going to use, doesn't tell me what to do. It doesn't say I have to complete the square or anything. So I'm going to say x equals -b over 2a. So I have -4 over 2 times 1. So -4 is going to give me 4 divided by 2 equals 2. Now, it's nice that these are coming out to be nice, pretty whole numbers. That does not happen a lot. A lot of times we get fractions, and that's okay. Fractions are our friends. So now I know the x part of my vertex is 2. That also lets me identify my axis of symmetry at x equals 2. That's that vertical line that cuts our parabola in half. So now I'm going to find out what y equals. I have y equals 2 squared minus 4 times 2 plus 3. So 2 squared is 4 minus 8 plus 3. 4 minus 8 is -4 plus 3. Y equals -1. So my vertex is going to be at 2, -1. So is that going to be a minimum or a maximum? Well, since this is a positive parabola, that's going to be my minimum point. That's the lowest that this parabola goes. The last thing I want to go ahead and try and find would be my x-intercepts, where the graph crosses the x. So I have x squared minus 4x plus 3 equals 0. So hopefully this factors. If it doesn't, we use the quadratic formula, no big deal. But are there factors of 3 that multiply to give me 3 and add to give me a -4? They do, x minus 3 and x minus 1. So I know I have 2 intercepts at x equals 3 and x equals 1. And remember, we're asked to find intercepts. So I write that as 3, 0, 1, 0. So let's go ahead and throw this all on our graph. I have my vertex is at over 2, down 1. I know it's facing upwards, which is awesome. My y-intercept is at y equals 3. So look, guys, my y-intercept is 2 units away from the origin. So I'm going to reflect on this side 2 units, and it's the same height. So there's my other point on my parabola. And then I can go ahead and plot my intercepts at 3, 0, and 1, 0. So 3, 0, 1, 0. And I draw a nice, pretty picture of my parabola. So the last thing you might be asked to find, since we found domain, is to find the range. Well, let's talk about range. Range, remember, guys, range is based upon the y-axis. We read it from low to high. So the lowest points on this graph would be -1, and the highest point is going to appear at infinity. So our range is going to be from -1 to infinity. If you have a positive parabola, your range is always going to be from the y part of the vertex to infinity. If you have a negative parabola, it's going to be the negative infinity to the y part of the vertex. All right, good job, good job. All right, let's look at the last one. This last one for today, and then we'll do some completing the squares and some other stuff when we come back after Veterans Day. But we're going to just find the vertex, okay? They didn't tell us how to, so we're just going to find it how we want to. We talk about domain. Right now, for all of the parabolas that we're talking about right now, our domain is always negative infinity to positive infinity. We'll talk about range in a minute. I can already identify my y-intercept. It's just my constant, remember? So my y-intercept is at 0, 7. All right, good. Nothing else we can really do just by looking. So let's go ahead and use that little formula that we know to find the vertex. I'm going to say x equals negative b over 2a. So I have negative 8 over 2 times 2. Negative 8 over 4 gives me negative 2. And again, we're coming out with nice, pretty whole numbers. That does not always happen. So be prepared for fractions, guys. All right, so now we know what x is. Let's find y. So y equals 2 times negative 2 squared plus 8 times negative 2 plus 7. Well, negative 2 squared is 4, and 4 times 2 is 8. So we have 8 minus 16 plus 7. 8 minus 16 is negative 8, plus 7 is going to give me y equals negative 1. So my vertex is at negative 2, comma, negative 1. And what direction is this parabola opening? Well, we know it's positive. It's going upwards because my 2 here is positive. So the last thing we're going to look for is our x-intercepts. How do we solve x-intercepts? We plug in 0 for y and we solve. So 0 equals 2x squared plus 8x plus 7. Now, hopefully this factors. So 2 times 7 is 14. Are there factors of 14 that multiply to give me 14 and add to give me 8? 1 and 14, 2 and 7. Ugh, they don't. So what does that mean, guys? Quadratic formula. I have x equals negative b, so negative 8 plus or minus the square root of b squared minus 4 times a is 2 times c is 7 all over 2 times a, which is 2 times 2. So we have negative 8 plus or minus the square root of 64 minus 4 times 2 is 8 times 7 is 56 all over 2 times 2 is 4. So now we keep simplifying. Negative 8 plus or minus the square root, 64 minus 56 is 8 all over 4. So keep simplifying, guys. Negative 8 plus or minus, I can break 8 into 2 squared to 2 over 4, and then we can simplify just one little bit more. Negative 8 divided by 4 is going to give me, let's just go by 2. So I have negative 8 divided by 2 is going to give me negative 4. Plus or minus, my 2's will cancel, so square root of 2 over 2. If you wanted to simplify more and simplify this as negative 2 plus or minus the square root of 2 over 2, you could, but I'm fine with you guys leaving it just like that. So we found out what our x-intercepts are. Are those beautiful and wonderful and you guys can't wait to graph those? No, but it is what it is. So our x-intercepts are going to be at negative 4 minus the square root of 2 over 2, comma 0, and negative 4 plus the square root of 2 over 2, comma 0. All right, the hardest thing about this, guys, is figuring out where that is on a graph. So if you want to think about it, the square root of 2 is close to square root of 1. So you could kind of think of this as like negative 4 minus 1 divided by 2, which would be negative 5 over 2-ish. And here would be negative 4 plus the square root of 2. So plus 1 divided by 2. So it'd be negative 3 over 2-ish. Just gives you an approximation about where that would be. So then we would go ahead and plot everything we know. We know that our vertex is at negative 2, negative 1. So I'm going to go left 2, down 1. I know that my y-intercept is way up here at 7. So if my vertex is 2 away on the right-hand side, then I know I have a mirror image point 2 away on the left. And then our intercepts are at about negative 3.5, negative 3 over 2, and about negative 5 over 2. And then our parabola would look something like this. All right, so guys, tomorrow, or not tomorrow, whenever we talk about this again, you guys are going to see sometimes you get nice, beautiful intercepts, easy to see. Sometimes you get these really awful radical answers, and then sometimes you get imaginaries. And what does it mean if you get an imaginary x-intercept? That means there isn't one. If you get an imaginary, that means it does not touch the x-axis. So you might see that. But let's talk about range. Our range is going to be from right here, -1 on the y-axis, and it goes all the way up to infinity. So our range is going to include -1 and go all the way up to infinity. And again, range is based upon the y part of your vertex. If I was going to talk about the axis of symmetry, that invisible vertical line that cuts your parabola in half, that's going to be x equals -2. So we need to know all of those wonderful things. So we will finish up these notes, guys, when our next class period, and then we will just practice this a whole bunch.